integration, and CD is continuous delivery, or it could mean continuous deployment. CI is continuous integration, and it's all about ensuring your changes work with everyone else's changes. Or said another way, your changes need to integrate with everyone else's change. So whenever you do commit, a build should happen to ensure at the very least the changes you made still build with everyone else's code. Next, tests should run, right? Because you want to maintain your quality from one check-in to the next. So we try to catch our bugs as early on in the dev cycle as possible. But wait, there's more, right? There's more to it than just building and testing. Ideally, anything else you care about when it comes to building your app should happen here. So things like linting or security auditing or maybe even scans for credential leaks or whatever else you need, they can happen right here. So depending on what you're talking about, CD could be continuous delivery or continuous deployment. Continuous delivery means at the end of each automated CI/CD pipeline, you have a deployable application or a deployable piece of work, a deployable unit, and you can pick that up and deploy it at any time. So this should include scriptable environments as well, for instance, like infrastructure as code, where even if no environments are provisioned, or if someone manually went in and configured your infrastructure incorrectly, you have everything you need to stand up your application correctly at the end of this pipeline. Continuous deployment, that takes it one step further and it actually deploys. So it may not necessarily deploy it into production. You might have CD into a test environment or a staging server with gates where you can promote this into production, right? But ultimately, continuous deployment is all about when you go to deploy your application, your pipeline is trustworthy and reproducible. You know the deployment into production is going to work because you did your deployments exactly the same way to your other environments. So my pro tip is always have continuous deployment to somewhere. Don't assume the version you just created is going to deploy as cleanly as the last version. So always deploy somewhere. All right, so let's talk a little bit about GitHub Actions. We've seen actions in some of the previous sessions. We've even seen examples of complex workflows around continuous integration. But we haven't really looked at continuous deployment with GitHub Actions. Now, we've seen actions can build our software, but what about deploying into production? So first of all, GitHub is an automation engine for any workflow related to your repository. And yes, we've been using it for CI/CD, but that's only one way to use it. You can run a workflow when someone comments on an issue, or when someone forks your repo, or even just on a regular schedule. In fact, there are dozens of different events that can trigger this workflow. However, it is very good at CI/CD, and it can deploy almost anything to almost anywhere. All right, so let's look at Tailwind Traders again. Tailwind Traders is a hardware supply company, and they want to make some changes to their application. So we're going to go through a CI workflow, and then we'll extend it to take it a bit further to deploy it all the way out to Azure. All right, so this is the Tailwind Traders website, and the marketing team has told us this recommended here, not descriptive enough. They want us to change it to recommended categories. All right, easy enough fix. We'll jump into VS Code. We can change our translation file, and we can make the change here. All right, so after we make the change, we'll go ahead and save this, and we'll check our code in. So this is just git commands. We'll do a git commit, and then we'll push this back up to GitHub. Now, as soon as our code hits GitHub, it's going to trigger our workflow. And our workflow is defined in this specific YAML file. So as you can see, anytime code hits main, it's going to trigger this workflow. And this is just going to go ahead and build our application and then run our tests. So if we come into the Actions tab in GitHub, we can see this workflow has been kicked off. We can drill into it. And we can see, yes, all it's doing is it's going to build our application and test it. It is not doing any deploying of any type at all. So let's go ahead and jump back into our workflow definition, and we'll add some actions that will do that deployment. So the first thing we're going to do is at the very end of this workflow file, we're going to add some actions to do some deployment steps, right? So the first thing we're going to do is we're going to add a .NET publish step. And this will create my deployable artifact as a zip file. So it's going to be my web app all packaged up and ready to be deployed. All right, so after this publish step, we're going to add another step that's going to deploy the packaged web app to Azure App Service. So notice we're going to pass in the publishing profile of this app service as a secret, right? So we need this to be able to deploy. And we're also going, let's add one more task in between this. I want to be able to upload my build artifact to this specific release, because potentially I want to do something with this build artifact later on in this workflow, maybe like in another job, right? All right, so we've added that. We'll go ahead and save our changes, and we'll go ahead and commit these changes back up to GitHub. So again, this is just your normal GitHub workflow. We'll do a commit, and then we'll push. And once we push our changes up to GitHub, once the code hits GitHub, it's going to trigger our action. And let's jump into GitHub and see what it's doing. All right, so here's our action. It hasn't started yet. Let's click on Actions again. And there it is. Awesome. Our action is running. We can click on it and we can see in real time everything that it's doing. So this takes a little bit longer to run because not only are we building and testing our application, we're also deploying as well. So as this is running, let's talk about some of the other options you can do inside of your build. So Github Packages is super useful if you are creating a reusable package that you want someone to download and use later. So things like Docker containers or NPM or NuGet packages, right? This is a great package management system, easy enough to use and add into your workflow. Another thing you can do with your build artifacts is you can upload it to a specific release. So this will allow you to upload your artifacts to a specific release as a downloadable artifact. And you can do that inside of your GitHub Actions workflow. And then you can download and use the artifact later on in your workflow, like for instance, in another job somewhere. So here's an example of how you can do that. All right, in terms of deploying to Azure, there's all sorts of things that you can do with Azure as well. You go to the marketplace, search for Azure, and you're going to find piles of actions of things you can do inside of Azure. What's really cool is all of these actions, the ones written by Microsoft, they're open source. So the source code is checked into GitHub, and you can read the code to see what they're doing, or you can even submit pull requests if you want to add features or to fix things. There's also a lot of documentations around how to use these actions, but one of the best pieces of documentation is examples on how to use these actions in real YAML files. So if we go ahead, let's go ahead and scroll down over here and click on Azure Starter Templates. Here you'll see plenty of examples of workflow templates that actually use real Azure actions. And if we click on Azure App Service, now we're going to see a bunch of workflow definitions as YAML files for Azure App Service. So if you're going to do something, we probably have a sample that we can use. All right, jumping back to the build, we can see this process, it's almost complete. We've built our app, we've uploaded our artifact, and now we've deployed our application as well. So if we look at artifacts, bam, there we go. We've really deployed or uploaded our artifacts back up to this specific deployment. All right, so now if we jump into production, we should see our changes, right? So let's refresh this, and instead of recommended, bam, it says recommended categories. Our change has now been pushed all the way out into production. So all we needed to do was check our code into source control, and automatically those changes were built, tested, and deployed into production. And that's great, right? But maybe we want to deploy this same app to lots of different environments, maybe even hosted in different places, like maybe hosted in Azure and also in our own data center, or maybe even in someone else's cloud. So guess what? Containers, they're a great way to do things like that. So we're going to remove all of this, and we're going to replace this with Docker commands. So what are we doing? We're going to build our application in a container, then we're going to containerize our application, then we're going to upload our container image into a container registry. So let's go ahead and do a commit, and we'll push these changes back into GitHub. Now, once we do that, that's going to, of course, going to kick off our action, our workflow, and it's going to run using this definition. So what is it doing? It's doing something pretty simple, right? It's going to go ahead and build our app in a container. It's going to create our application in a container. It's going to create an image for that, and it's going to upload our container image to a container registry. So let's jump into the Azure portal. We can look at our container registry. You can see we already have some container images here. That's awesome. And now if we jump back to the workflow, as soon as it's finished, that means it's uploaded our container image up to our container registry. So jumping back into our portal, this is our container registry. Let's refresh this. And now you can see our workflow added a new image to this repo. And we've tagged our images with latest, if it's the latest build image, and also with the SHA from GitHub. So everything is super traceable. And we also have an Azure App Service that's connected to this, and it's pulling images from this registry. In fact, every time there's a new latest tagged Docker image, it will automatically pull it down and deploy that Docker image into production. So bam, there's our code running up in production, just like that. So this is a super cool way, a super cool workflow of getting our code into production by using containers and container registries and hooking Azure App Service up to our container registry. Okay, so we've seen a couple different examples of pushing to production, but we probably don't want every one of our changes to go straight into production. Now, if we follow trunk-based development practices, working mainly off of trunk, then any commit to main branch, that's going to deploy to production, right? But we don't want that, at least not initially. We want some opportunity to verify that our changes look good and it doesn't break anything. So what are we going to do about it? We've spoken in other sessions about working with pull requests to make sure there's an opportunity to check any new code before it gets merged into the main branch. And as I've mentioned, there are dozens of events that can trigger workflows, and pull request is one of them. So now during a pull request, we can build that app, test that app, then we can deploy that app into a staging environment that's specific for that pull request. So now we can test the outcome of our changes before it's merged into the main branch. Or in other words, we're applying checks before merging back into the main branch. So there are quite a few trunk-based pull request workflows that work really well, but here's one that I really like. So this blue line here represents our trunk or our main branch. And as work gets done, a short-lived feature branch is spawned and work is done in there. So these short-lived feature branches, they represent the work we are doing, and it's important that they are short-lived. We don't want these branches to live for a long time. We don't want a month's worth of work stacking up inside these branches, because that's when merge bombs happen. So we're really talking about days here, max. Now, when we are ready to release or deploy something to production, we can create a release branch off of the main branch, and this will be used to deploy our code. And you can do the same thing with tags or with the releases. I really like using branches because branches are super cheap in Git, and it's also a nice way to archive everything that changes. And also, if we need to do hot fixes, we already have that branch ready to go. All right, let's take a look at pull request workflow in these short-lived branches. When we do a pull request, we can run a workflow, and at the end of that, we can deploy our application into a separate environment for each and every one of these feature branches. Now, when these short-lived branches, we can merge them into the main branch. And then we can have workflow that will go ahead and build and deploy from our main branch. So this automation means all we need to do is submit a pull request, and the newly running code that is tested on is then deployed. And when you do a merge into master, you get the running application in a certain location as well. But that main branch, what does that mean? Does that mean it will go into production every single time? So that is one option, but you never know for sure if the merge is going to work exactly as planned. And more importantly, you don't know if that merge will provide the value to your end users, which is what DevOps is all about. So what we really want to do is test our changes before we go into production. So one way to do that is we can pick these deployments off of main that work and promote them to the production environment. So our main branch doesn't deploy to production, it goes to some staging environment first, and when we decide this specific release should go to production, we can release that. We can create a release branch and promote that specific change all the way out to production. Now, there's a number of ways to do trunk-based development, and all of them have their pros and cons, and this just happens to be one that I like. There's also a lot of different ways to promote these deployments into production. The important thing is you should be deploying the exact same artifacts from one environment to the next, right? So I said this carefully. Make sure you listen to what I say. You shouldn't have to rebuild. We really need to use the exact same binaries that we deployed in our staging environment and promote those exact same binaries into production. All right, so yes, there are a lot of ways to do this promotion. But one super cool way that I want to show you all is using a technique called ChatOps. ChatOps is using your chat application, whatever that may be, to control your deployments in a nice way that keeps you in the tool that you're using in your collaboration. So next, we're going to implement ChatOps. We'll use Github Actions, since our code lives in GitHubs, and we'll deploy using Azure App Service, since our app is hosted in Azure App Service. And of course, we're going to use Microsoft Teams as our chatting app. And as we saw in the Getting Started with DevOps session, Microsoft Teams is an amazing collaboration hub for Tailwind traders. And we can add even more collaboration features into it by implementing ChatOps through Microsoft Teams. So first, let's look at how we can implement something like this with Azure App Service. Now, App Service has this really cool feature called deployment slots. You can think of deployment slots a bit like a shadow version of your app. So it shares an app service plan, but it's a completely new instance of your front end. But you can direct some traffic to it. So it's a great way to deploy your application because it's essentially you're deploying into production, but it gives you a chance to test things out before pushing it live to all of your users. Now, initially, maybe you have 100% of your traffic going to the production slot and you deployed into the staging slot. Then you can test out the staging slot, and when you think everything looks good, that's when you can swap those slots around. So now all the traffic is now being redirected into your staging slot, and what was your production, that can now be your new staging slot. So this is a really nice way to implement a blue-green environment. And swapping slots is super easy too. You can do that from the Azure Portal UI, or you can use the Azure CLI. Another thing you can do is direct some of your traffic to the staging slot. And this will allow you to test it and let some of your users see the new code just to make sure everything is okay. And if it's not, only a small portion of your traffic saw that bad code. And it's easy enough to swap that out, right? So next, you can slowly, if everything's working, you can slowly open that up traffic to more traffic and then to more traffic until eventually 100% of your traffic is now using that new slot. So something like this is you can use for canary deployments, or this is also like doing safe deployments. And using slot is a great way to implement this. You can also implement this in different ways, like using feature flags, but slots, super powerful. You can totally do canary deployments and also safe deployments. But how are we going to trigger this swapping, right? We're going to do that inside of Microsoft Teams. As we saw in Getting Started with DevOps, Microsoft Teams is a great hub for team collaboration. It's not just for chat, and it's not just for calls and sharing documents. There are lots of extensibility points that allow you to really use it as your hub for anything project related. Now, there are piles of wonderful stuff available with conversational bots, with customizable tabs, messaging extensions, so on and so forth. But for our purposes, we're going to be talking about connectors and webhooks because that's what we need to really integrate with GitHub and Azure to help with our delivery, our software delivery. And now we can do all of this without leaving Microsoft Teams. Also, we'll be using a cool features inside of Teams. Instead of just dumping messages in the channels, we're going to use something called an adaptive card. So these can give you powerful interactive containers so you can actually do work and make things happen rather than just see status updates. All right, so here's the plan. When a PR is merged into the main branch, this is going to kick off automation and will deploy the build to a staging slot. Next, GitHub will go ahead and send a message to Teams that a new deployment just occurred using an adaptive card. And this will say a new deployment occurred. It will have links to the new staging slots, and we'll have a button that will promote your changes into production. So after seeing this message in Teams, you can go directly to the staging slot, test everything out, make sure everything looks good, and if it does, then we can click that promote button, and this will trigger the promotion or the slot swap, and then the staging deployment will be promoted to production. All right, super cool. Let's take a look at this in action. We'll walk through this workflow using Tailwind Trader's website. Again, we need to make some changes, but this time we'll be a little more safe with our deployments. We'll deploy into a staging environment, test it out, and then promote those changes into a production environment. In fact, we're going to take this one step further and go through a pull request first. So here's our website again, and this time the finance department came to us that this free shipping that we're doing, that's not going to fly, man. It's costing us too much money. So instead of free shipping, they want us to change it to cheap shipping. All right, easy enough. I've made those changes already, and if we jump into VS Code, we can see some of the changes that I've made. And I've made these changes in the cheap shipping branch. And when I checked this branch in and issued a pull request, this kicked off my automation, which built this branch and then deployed it into staging. So this is my production branch, and as you can see, the changes did not deploy to production. It deployed to my staging pull request site first. So here you can see in our Teams channel, GitHub alerted us to the pull request. And that came from the GitHub Enterprise connector. So here's where we configure our connectors, and we configured this to send events from GitHub, our project in GitHub, to this specific channel. All right, so now, if we click on the View in GitHub button, this will allow us to view the pull request directly in GitHub. And here we can see exactly what changed, and in this case, we changed free shipping to cheap shipping. All right, we can also see this build kicked off our pull request build workflow. So clicking on the details, we can see exactly what happened in this workflow. Now, part of this workflow, it deploys this to a pull request staging environment. And what we want to do is check that out, make sure it looks good, and see if this is something we want to promote to production. All right, so let's go ahead and jump to our pull request staging slot. We'll go ahead and refresh this. And free shipping then changes to cheap shipping. Yay! Our changes hit our pull request slot. It looks good. So what we want to do now is merge these changes into the main branch. So let's just jump back into Teams, because now we can go directly to our pull request, and we'll merge this to our main branch. All right, so once we merge our changes, it's going to, of course, kick off our actions. And here we can see that it kicked off. And now we can jump in here and we can watch it run through. Right? There's an extra step configured now where we send a message to Microsoft Teams. So yes, it builds, it tests, it publishes, it deploys it, but it also sends a message to Microsoft Teams. So what that's doing is we're sending a message from here, hitting a webhook in Teams, and it's sending an adaptive card to our chat ops channel. So if we jump into the chat ops channel, we can see that adaptive card where it says deployment has completed. And there's also a deep link to the commit which triggered this automation. And if we click on this, it will take us directly to that commit in GitHub, which shows us exactly what was changed. Now, going back to that adaptive card, we can click on the open staging site, and this will take us directly to the staging slot. And you can see cheap shipping has made it to staging. Awesome. But it still hasn't made it to production yet, right? Hasn't made it to production. So now we can jump into the Azure portal, and in theory, we can just swap the slots here, right? But jumping around in different tools is kind of a pain. Plus, in Teams, we have that adaptive card, where if we press that Promote to Production button, if we click it, it's going to hit an Azure function, and in the background, it's going to use the Azure CLI to swap slots. And now we get an updated card that tells us the application was promoted to production, with a button to see the production site. So let's go ahead and click it. This will take us to production, and now we can see, let's refresh this, instead of free shipping, it's now cheap shipping. It's made it all the way into production. Hooray for that. So we're looking pretty good now. We have continuous integration. We have continuous deployment workflow, and it's using GitHub Actions, Microsoft Teams, and the power of Azure to make sure we're deploying our application out to Azure. But our production environment is now protected, and we have an opportunity to check it out in a staging environment before we promote those changes to production. All right, one thing we pointed out a bit in these demos is the idea of keys, secrets, and credentials, right? When you deploy your application, there are places you're going to need to pass in passwords and secrets to authenticate. For instance, when we deploy to Azure, we have to be able to authenticate with Azure. There are also keys and settings and credentials that our application needs just to run, things like connection strings, API keys, and these need to be set during deployment. So all of this stuff should not be in source control. In fact, GitHub will alert you if you accidentally leave a key in source control, right? Because now you're leaking out your secrets to the public or to a lot of people that shouldn't have them. So how do you handle secrets? Now, right out of the box, there are GitHub secrets. So in GitHub, for each repository, there's a place to securely store secrets that can be used in your workflow. Here, we're using it to store the publishing profile for our deploying to our staging site. Now, we have to create the secret out of band, so it's not in your code. It's safely stored in a separate location. Right. So to set this up, it's easy enough. Again, it's specific for your repository. You go into the settings, secrets, and here you can create a brand new one. Now, if you do this, you'll notice that there's no way to view these secrets once you stored them. You store them, they're encrypted, and now no human being will ever be able to look at them again. And even if you use them in your GitHub Actions, GitHub does its best to strip them from all the log files, so you still won't be able to see them. But as good as this is, there are some limitations. The secrets might be used in a number of places. So if they're changed, now you're going to need to change it in every single repository that uses this secret. And the key here is you got to remember where they all are. So this is particularly important in the case of an emergency or a security incident where you need to kill all your creds immediately and quickly recycle all of your secrets, right? Trying to remember where every place that uses them, that's really difficult. If you don't remember every repo, deployments are going to break, right? So it's also generally a good practice to cycle your credentials often. So now the person in charge of controlling these credentials, they also need access to every repo that uses them. So if this is your ops team, you can see this does not scale well at all. In fact, it scales pretty badly. So another great way to store your secrets, and not just your secrets, but your keys and certifications as well, is in something called Azure Key Vault. This can be integrated with your other Azure resources, giving us a central place to manage everything. So Azure Key Vault allows you to have a single point of control, and it's also managed by Azure Active Directory. So sensitive information is centralized, and it's managed by the appropriate people. And the workflow simply pulls these credentials just before they need them, and is using another Azure credential that can be controlled centrally as well. So let's take a look at what this looked like. Here's our workflow that uses Key Vault action from Azure to retrieve the Docker password from a specific Key Vault. It's stored in the output variable with the ID KV secret action. And then in the next step, we use that stored secret with the Azure Docker login task to log into Docker. So if we need to cycle our secrets, all we need to do is make those changes to our secrets in Key Vault. We don't need to make any changes to the workflows or in any of our repositories. They will just work. They will just pull those secrets down and everything flat out works. All right, so let's take a look at this in action. Again, we'll be using our Tailwind Traders website. So we're going to jump back to our first demo, and just after we change our workflow to use Docker for our deployment. So what we're going to do, what currently it's doing, it's using a Docker password that's stored in secrets in GitHub. And we want to change that by pulling these from Key Vault versus using it directly from GitHub Secrets. So to do that, we'll add a couple of actions here. The first, we're going to go ahead and log into Azure, and we'll use the credentials that are specific to this application. So if they need to be reset, we can just reset it for this specific application. After logging into Azure, we want to get the Docker password from Key Vault. So we'll use the Azure Get Key Vault Secrets action. And finally, in our Docker login, instead of using the Docker password from GitHub Secrets, we'll use the secret from Key Vault by referencing the output variable in Docker password. So again, we're logging into Azure, we're getting the specific secret from Key Vault, and then we'll use that secret, and then nothing else has to change. So let's go ahead and commit this, and we'll push those changes back up to GitHub. Okay, so once those changes hit GitHub, it's again going to kick off this action using this specific workflow, right? So this right here is Key Vault. You can see we have our Docker password, and we can also see that this is a place that you can store your secrets and also your keys. Now, it turns out I don't have any secrets or keys or certificates, but if you had some, you would store them here, right? All right, so we have no keys, we have no certificates, but we do have that one secret. All right, now jumping back into action, we can see that our action has kicked off and our workflow is now being triggered. Now, if we jump into this workflow, we can see that it's running. And again, it's not doing anything magic here, but this time, instead of getting our secrets from secrets in GitHub, it's pulling the secrets down from Azure Key Vault, and then it's going to go ahead and use it. So we've seen some pretty cool things with GitHub Actions and Microsoft Teams and Azure App Services all working together to enable us to deliver change to our customers. But we can do so much more too, and our imagination is really the limit here. So we can do all sorts of stuff in our automation tools. So for instance, maybe we want to rotate the credentials in Key Vault for our app. And maybe we want to do this when an admin just asks the team bot to do it. Guess what? We can do that using integrations with Teams to hit the Azure API, rotate the credentials. And the next time we deploy our app, guess what? Everything just works because our workflows pulls these secrets down from Key Vault. Maybe we want to automatically build a new developer environment and fork a repository into their private repository based on a properly formatted issue in GitHub Issues, right? So this isn't something that I'm just making up. I've actually seen this happen. So there are people where if you create an issue in a specific private repo, it will automatically create all of your resources up in Azure using ARM templates, and then it will fork that repo into your own personal account. So now you're ready to make changes and fix this particular issue. All right, we can also do things like pull the commit messages since the last production release, so we can automatically build release notes, right? So our imagination is a limit here. With Actions, we can have workflows that automate just about anything inside of GitHub. There's also a repository dispatch event that can be used for any external application. So if you registered this correctly, any external app can now fire repository events to GitHub, triggering your actions. So we've covered a lot of stuff here. So to summarize, add CD to your pipeline, whether it's continuous delivery or ideally continuous deployment. I think it's important to continuously deploy somewhere. It doesn't have to be production, but continuously deploy to a test environment is super valuable. It means not only have you built your app and your tests passed, but you also know your app will deploy successfully. And moving to production will probably work because you've already done this in your test environments. And if you use containers, you can feel even more confident things will just work. Ultimately, though, it's about protecting production. You don't want to deploy all your changes directly to production, and one way to do that is using ChatOps. By using Microsoft Teams and its integration points, you can send adaptive cards that will allow people to do work of promoting changes to make sure the changes are working. And finally, I think it's really important to centralize your secret storage like using Azure Key Vault. Yes, you can put your secrets directly into GitHub Secrets, and you absolutely just don't want to put it in source control. That's the key. But putting all of your secrets in Key Vault, that means you can manage them in a much cleaner way. And if you want to learn more about what we've talked about today in this session, go here and do this Learn Path, which will teach you how to author automations using GitHub Actions. Similarly, if you want to learn how to collaborate with teams and you want to learn how to do that, here's another great Learn Path that does that as well. So go ahead and check that out. Also, there are plenty of documents on Microsoft Docs, so go here to see all the docs about the Teams integration and writing those Teams integration. And if you want to learn about Azure Key Vault, jump in here, and there's all sorts of docs and learn modules about Key Vault. And finally, thank you all so much for joining me. Hopefully you learned some great DevOps information, and stick around to the next session because we're going to do even more cool DevOps. Thank you.